Okay, this is our Arrhenius equation part 2, and this is a second problem. It's a little bit more advanced than the last problem, but we're going to do it by the same process. So I'm told that I have a rate constant that is 4.6 times 10 to the minus fourth, and I have a temperature that goes with that, that's 350 degrees Celsius. It says the activation energy, so E sub A, is 104 kilojoules per mole. It wants to know what is the temperature, so that's my question mark, with a rate constant that is 8.80 times 10 to the minus fourth. Again, the equation for this is going to be the natural log of K2 over K1 is equal to E sub A over R times the quantity of 1 over T1 minus 1 over T2. So this temperature needs to be in Kelvin, and that's 623. Okay. The activation energy has to be in joules, so it's 104,000. Temperature is what they want to know, and the rate, give me a second, rate constant. Now, again, because this mathematical equation, it's going to be easier mathematically, but it doesn't matter in reality. It's easier mathematically to solve for this T1. So I'm just going to look at my equation before I start and before I do this, and so therefore this is going to be 2, and this is going to be 1. It's still mathematically, and you can still get the same answer if your unknown is T2. It's just less mathematical steps if I make it T1. Okay, so I have natural log of K2, which is my 4.60 times 10 to the minus fourth, divided by 8.8 times 10 to the minus fourth is equal to 104,000 divided by 8.31. This is my unknown, T1, minus 1 over 623. Since I have both the top and bottom of this fraction, I can do this. So natural log of this fraction gives me a negative 0.6487. Taking 104 divided by 8.31 gives me 12,515.0. So that still leaves me 1 over T1 minus 1 over 623. So I'm going to divide both sides by the 12,515, so negative 0.6487 divided by 12,515 gives me 1 over T1. I can lose the parentheses now, 1 over, and I'm going to go ahead and, no I'm not, gives me minus 0.623. So dividing these two gives me a negative 5.18 times 10 to the minus fifth, 1 over T1. Now I'm going to take this 1 divided by 623, and I get 0.001605. Okay. Now to isolate this fraction, I'm going to add this 0.001605 to both sides. So I take a negative 5.18 times 10 to the minus fifth plus 0.001605, yeah, that was a 6, is equal to 1 over T1. So when I combine these two here, I get a 0.00153 is 1 over T1. So now I'm going to take 1 divided by this 0.001553 to equal T1. So I'm taking the inverse to both sides. And so T1 ends up being 644K. And that ends up being my answer. Does this make sense? Okay, so if I look at my K's, my rate constants increased, so I expect an increase in my temperatures, and it did. It went from 623 to 644. Now this one doesn't specify the units. It could ask you in degrees Celsius, at which point I would just subtract out the minus 273 from the 644. And that is the end of this video.